Mr. Murli Gopal Krishnan. One of our delegate has asked, it's a very technical question, I believe. It's what is he says IEC 61850 protocol. Details he want to know what it is actually.
Mr. Akilur was mentioning, that's a protocol that's been prevalent for maybe 40 years. That works on a multicast mode, on a broadcast-based mechanism on UDP protocol at the protocol level. Yeah, from information model standpoint, that has something called GOOS, which is a generic object representation of each of the sensor data, and each of those sensors have to conform to that information model and broadcast it, and the respective devices or respective network elements that participate would be picking up that information and then processing it for further real-time management of the data. So maybe, yeah, that's a larger topic to explain a protocol itself. But in short, I would put it this way: it works on a broadcast mode, and it's a application protocol, works on UDP, and the information model is governed by something called a Goose model. Maybe if Anirudh wants to add anything to it.
No, that's great. Yeah.
So I hope Mr. Yadav would be more eager to answer the question. Question is like, what are the industrial demonstrations and use cases for the adoption of AI machine learning? This is one of our attendee.
So basically, if I talk about AI and ML use cases right now, where I am seeing it is basically in maintenance side. If you see from the substation maintenance, so it involves a lot many risks, right? So with the use of AI and ML, because we have nowadays we have huge data coming in from the SCADA system, from BMS system, right? So and also from the real-time feed cameras which are already there at substations. So I'm talking about from the transmission side. So if we have all those data together, we can actually build on top of that based on AI ML use cases in terms of doing the maintenance or running the maintenance steps in virtual environment. So it will mimic all those things directly from your substation. You will see like the live feeds, how it is happening, and then you can train your maintenance crew, and when they go live to do those jobs, they can perform very well. So this kind of POC, which is already there. I mean, right now the things are happening in the POC's form, and there are several use cases of AI/ML you can have in predictive maintenance, right? So where you have assets data like from transformer or from other asset data, you can actually utilize to predict the faults where or to predict the failure of your machine when it is going to fail in the future. So those kind of scenarios can be built as part of the use cases of AI/ML.
Yeah, may I add to very specific, like we as Hitachi Energy, as he said, Yadav Anil said that it's used for predictive maintenance strategy. Basically, when you have the sensors in the transformer, in the switchgear, in the substation, so how you take the data and you can have the model, the AI/ML model, which will predict the failure or malfunction of the transformer or assets. And that is something we also use in our asset performance management solution. In addition to the predefined algorithm, AI/ML also helps in getting the data and predicting on top of the predefined models. The second application of AI/ML in energy space, the electricity, is also the energy forecasting, where especially the renewable energy forecasting in terms of solar energy or wind energy. As we know, this is intermittent and also depends on the weather. But there are a whole lot of other factors which leads to final generation of this kind of renewable energy. So whether it is also the condition of, let's say, the solar panels, the inverter, the converter, and then entire equipment, and also the dust, irradiance. So many things are there. So how do you predict that? So there AI/ML is used. And of course, in future, We are also going to use AI/ML for protection and control. But right now, it is in a learning system where we get the data about the protection and control from the relays, from the IDs, from the SCADA, and build this learning model based on AI/ML and then develop algorithm, because AI/ML cannot be used directly in the protection and control because it's a real-time protection and control, and then it has to be 100% accurate. And AI/ML cannot give you 100% accurate prediction as of now, but over a period of time, the AI/ML system can be running in the system in a learning mode, and then finally it can achieve that accuracy. Yeah.
Question is to Mr. Shahpure. You have been associated with the Pune Smart City Development Project. We would like to hear your experiences and what has changed now since then.
It's a year back when I was affiliated to Smart City for 3 years. The mission, the specific mission which was started in 2016, which went well in terms of putting up 100 smart cities was not an simple task for developing country like India. On the other hand, it was been expected that in a very layman's language, I can say, like, if I'm coming out of the house, I will be having an metro in my door, or also an aircraft which will be which will take me to the nearest airport. Whatever. I mean, that is what it was expected. However, we have to look at this particular one as a lab set up in various parts of India. The 100 labs they have set up, and then they have experimented some of the things which we wanted to implement in the view of having this in a citizen centric view, how we are going to make the cities livable. It is not something which is, we wanted to copy Bogota, we wanted to copy New York. No, or maybe like, I mean, when I'm living in Nasik, I don't want to copy Pune, or I don't want to copy Bangalore, Mumbai. However, the test labs which have been set up, I would say like that we have got a way how we are going to satisfy the citizen living in that particular place. So some of the things which have worked in Coimbatore might not be accepted in Jaipur, or whatever it is been put up in Pune. Maybe it is the similar way what we can put it into Dehradun. So this is where all of these different kinds of activities, different kinds of projects which been laid, where it has been segregated into different like infrastructure, then command control centers. So what was the common in that particular one? That command control centers. So we have about 100 command control centers which are been exclusively used in some of the cities which they were running, and one of these is Pune. I was the session director at the time, as an additional responsibility for me for controlling all the COVID operations. And imagine, we have done excellent job while sitting into that. We have been accessing all the data from there. We've been processing all this data. These are the cases which AI/ML we have worked on actually. So all of data has been processed there. We have actually created a simulating model of containment zones, how the corona has been spreading on that. So these are the specific, and it is a complete different topic altogether, which I can go on talking about 2 or 3 hours or 4 hours. You have my videos, we can check it out. So there is no difference. What difference we have now, that we have understood the cases, and now it is a time to implement this in other cities, spread it across, and improvise the cities which have already been done. So that is what the next step is.
Thank you so nicely explained about it, your experiences. So now this is a turn to Mr. Gopal Krishnan. You have been waiting for long. So, like, question, you can move on. What you were commenting previously. We were talking about AI/ML, but there is a question which I would like to ask. is which specific technologies have been instrumental in ensuring a reliable power supply in smart cities? Mr. Murali Shankar Gopalakrishnan.
Question: reliable power supply in smart cities. Okay. Okay. So somebody else would want to contribute to that question? So yeah, so what I was adding to Mr. Rahman was like one of those use cases that is active in the industry, on the energy industry, is the demand prediction, which enables the prediction of the demand over different courses of time, which enables the power trading. A few other aspects that we at Fluent Grid have been actively working on using the AIML technique is predicting the pilferage in terms of based on the consumption pattern, raise a possible anomaly, and then there are field visits happening, and based on the feedback back from the field visit, continuously train the model to improve the prediction of the pilferage so that the hit ratio of identifying a pilferage is much higher is something that we are working towards, number one. And number two is on any AMI rollout, one of the key problems, especially on, or rather only on cellular communication, is identifying the pattern of the signal strength in the devices, which is the meters in our case. So based on the pattern of the signal strength, to improve the hit ratio of ability to gather the meter reads within the defined SLA that we have in our DSS scheme, be able to identify the pattern of the signal strength and predict what time would be the right time to poll the meters for the meter reads is something that we are actively working on as well. Just wanted to add to that.
So I'll be heading to now Mr. Rahman, continuing with the discussion. It's like, could you provide details on the specific innovations that play a crucial role in establishing a connected grid system? You were talking about the grid system. So
the connected grid system, when we say in future, it is going to be system of systems, because I mean, so far we talk about one grid, but in future it is going to be several smaller grids, microgrids, with its own storage, with its own renewable power, for example, rooftop solar, or even storage, battery energy storage, and also the green hydrogen based storage, and of course the EV. So in future, the connected grid would be that it would be a system of systems. You can say grid of grids, microgrid and normal grid, and then they are connected. And at the same time, when there is any emergency or any the resiliency issue, whether it is man-made or maybe weather or natural disasters, in that case, the system should be able to work in isolation, providing power to the critical infrastructure. I think energy storage, the protection and control based on the system of systems, where you have different grids running in conjunction at the same time, they can switch to individual operations. So these are the technologies which are going to be very important. And of course, in future, we are also going to see the medium voltage DC. So high voltage DC is something which is used in transmission, but in future it will also be used in the distribution more and more to control the power better in real time, and especially when we don't have the inertia in the system, because we'll be losing the rotating mass in the system, the generation. So these are the technologies which are going to be used. Of course, the EV, electric vehicle charging in different speed, fast, ultra fast, flash charging. And at the same time, another element which is very important is that having the prosumers in the system. So how do you do the energy exchange? When the consumers, they also can be producers, they can be provider of energy, for example, whether it is household or the big complex where they have rooftop solar, and also the storage, for example. So whenever they don't need power, they can always feed it back to the system, the grid, and the grid should be able to take that. And also there should be, let's say, blockchain based smart contract among different prosumers to trade energy in this space.
Nicely explained, sir. Thank you. So this is a question from Mr. Yadav, Mr. Anil Yadav. It's like, which specific technologies relating to electricity means contribute to the development of smart cities? There are certain specific technologies. So
Yes. Basically, yes. So see, so when we are talking about a smart city, I mean, you had one previous question also, like reliability of power in smart cities. So I mean, I would correlate those questions, and I'll try to answer both. So basically, what happens in terms of technology, if we see, so smart cities and smart electricity. So I mean, smart electricity is one part, definitely, right? And everything is driven from the electricity, because then we will be having smart water, lot many things you can add on there. Technology side, definitely, first of all, which I can think, you should be having at least city-wide DMS system, distribution management system, which I see, to first of all, so that your power should be reliable, right? Your outages should be reduced. You should be having your OMS, outage management system, in place. And definitely, as part of RDSS, we already know, like, there are cities which are marked, which needs to be and identified, where SCADA DMS should be implemented, right? So first of all, your automation system for a city should be strong enough to at least see network wise where the fault is happening, how fast I am going to rectify those faults, how I am going to improvise my SAIDI and SAIFI reports, basically, which is actually your performance reports when it comes for the reliable power, right? And after that, definitely, it would go towards, as Atul sir was already saying, now we are living in the area of prosumers, where uh, consumer will become like he will be having his own EV. He can actually supply power to the grid, right? So in a city where we see those kind of ecosystems, where VPPs are there, virtual power plants, where we say where the supply can be given, as well as it can it can become a microgrid kind of scenarios, where it can also become a part of microgrid and then connected to the grid, right? Where it can first cater the needs of the overall city, and then whatever the surplus is there, definitely it can go to the grid for betterment of that city, right? So in that direction also it can be thought of. So in terms of technology, dumps would be very beneficial, like distributed energy resource management. Once you have DMS, you have lot many resources, from battery energy storage, you have EVs, you have got your solar, wind, or rooftop PVs in cities. So all those things can be managed, visualized in a DRMS systems. So these are the technologies which can be leveraged. And absolutely, I would say smart meters are necessary as part of the RDSS scheme. That is also that transformation has already begun, right? So smart meters are already going on. Yeah, so this is from my side.
thank you, sir. So this is coming to Mr. Gopal Krishnan. It's like, how do you see the evolution of smart electricity technologies shaping the future of power sector?
Yeah, very good question, Sohan. So today we are talking about that particular topic, as Mr. Rahman and probably even Anil was talking about that topic, where we are talking about multiple connected devices, which is producing the data. So what are we going to do with the data is the key question that we have to answer for ourselves in the industry. While there's a lot of impetus today on the smart metering, which is the key in gathering the data itself, with that data, what more can be done is something that's very important in terms of converging the data with the other data that is gathered as a part of the electricity grid, which is including the substation monitorings and the solar panels data and the EV charging station data. All that data gathered together, construct a data warehouse, and create insights out of them to enable a more stable and quality power for the consumers, I think is something that should be happening once we have a much more penetration of the smart meters in the ecosystem. And as we talk, we also see some or significant initiatives on integrating the SCADA systems with the AMI systems, which would enable constructing of these data warehouses, which is going to be the backbone of managing the transmission and distribution system itself, and probably even to the extent of the way Mr. Rahman was talking about the blockchain and the smart contracts, which would also enable probably a automated scheduling system eventually, where based on the forecasted demand for the next 6 blocks of intervals, adjusting the scheduling automatically is something that should be looked at, and so that there would be lesser deviation settlement that will happen. So lots of use cases that was going to drive the automation of the electricity grid based on the data that we gather from these devices that is already spread and being implemented in the electricity grid ecosystem.
Yeah, nicely explained, sir. This is a question to Mr. Rahman.
Yeah.
It's like, what opportunities and challenges lie ahead, especially relating to renewables, the smart electricity paradigm?
I mean, if you look at India as a country, I think we have very good potential for the renewable energy. So opportunities are there to set up a large, utility scale renewable energy systems, plants, basically the generation, whether it is in places like Himalayas or in the desert or maybe even offshore wind. So huge potential there and opportunity. Challenges, of course, are there right now. How do you transfer that power to the load center? So evacuate the power and transfer it to the load center. So those will be challenges, because setting up a renewable, let's say, solar plant would not take much time. And it's for sure that you get the power, sun, your input cost is almost zero, the raw material. I mean, of course, you have the infrastructure cost. But having the transmission system which can deliver the power to the load center or to the nearest point in the grid, that is something which is challenging in terms of the time and also the money. And more than that, also technically it has to be simulated. You have to plan in a way that you plan for the connection, whether it's HVDC system which will deliver this power to the grid, short distance or long distance, or even a city in feed. For example, we are executing now a project for Mumbai using HVDC VSC technology for Mumbai city in field of power. It's not a long distance transmission, but short distance. But this kind of challenges, the opportunities are there. At the same time, challenges, how do we make it faster in terms of implementing this technology, having the right of way for the transmission system, where HVDC definitely helps in terms of having less footprint for the transmission lines, for the towers, even for the cables. Even like places like Mumbai, it takes less footprint, the space, than the conventional AC transmission line. So both challenges, opportunities are there, and opportunity in terms of technology, whether it is HVDC technology, flexible AC transmission technology, STATCOM, filters, distributed energy resource management. So all those technologies are there in terms of opportunities. Yeah.
Yeah, thank you, sir. Nicely explained. Mr. Shahapure, your comments on this?
The future technologies, that is what, and then the possibilities pertaining to my talk today. I will just put it up. A huge opportunity. The thing is, we have to understand what kind of risk which we are going through. It's not only the one which we are talking about, the conventional computers which we are going to face with the next quantum computers. The basic thing is what we always say: if it is not measured, we cannot control it. So we have to have then thorough assessment of the systems which are right now we are putting. We have to have the complete analysis. The data is already there. we have these loopholes which we can actually put, and then there is a lot of task force which is required to this. So opportunities uh, in terms of development, in terms of employment, and in terms of the product requirement is huge, where each and every system, you can actually very many students right now, when I interact with the university students, they are working on such a systems like even the grain ciphers. So it can be actually used on the top of the IoT devices, where it can actually have a lesser power and more security. So it's enormous opportunity. The challenges are there. So obviously, I mean, you can actually pull out Anil's first slide, and then check it out on the left side. These are the opportunities. That is where actually it lies. So we can go ahead and have a better future, a secure future. That is what I can always mention.
Yeah, thank you, sir. Closing statement from Mr. Anil Yadav, so that we can proceed ahead to Vivek. Vivek will then take up the discussion.
Basically, we already know, like, smart electricity is a journey. I mean, it's a, it's a ecosystem where we have to leverage the technologies of the future as well as what we have, and then we have to lead towards sustainability to keep the lights on. Basically, whatever the technology we are discussing, whatever the overall ecosystem what we have in India, we have to see and we have to integrate step by step, and then we need to go for the net zero.